Hey guys, Stat 1150, entering into what's called correlation and regression. And at the end of the day, correlation regression just begins what is maybe, guys, I'm not talented enough to write and talk, what we call two-variable statistics. And I really feel that correlation regression, this two-variable statistics component of your class, is probably the most applicable. When you go back to your field, whether it's nursing or psychology or engineering, this these concepts are things that you're probably more likely to see in your field. And I tell you, it is some of my favorite stuff to teach too. Maybe that makes me just like the ultimate geek by saying that, but I enjoyed teaching it. So, what's happened so far is we've been in one variable statistics, and we may have, a variable like high school GPA. So let's say we've got the high school GPA on some students, but we'd like to come in with a second variable and look at the first year college GPA and see if these two things are related. So when we see something like this, we would say, are these related? Now, assumption number one, both variables must be quantitative. Now, it doesn't mean we have to throw the baby out the bathwater, just completely forget the problem if these things turn out to be categorical. There are statistical procedures and techniques that we can examine the relationship between two categorical variables. This is not it. We use chi-square and odds ratios and things like that, but we're not going to learn that in this class. The assumption here is that both variables are quantitative. Excuse me. Now, the first thing we'd want to do in examining this relationship being consistent with the book is to see the data and to summarize it. Well, what we do in this situation when we have a two-variable statistics is we create what's called a scatter plot. So if we have a one variable and we want to look at distribution shape and see if there's any outliers, then we look at a histogram or a box plot. But if we want to look at the relationship between two variables, that's the scenario that I set up right here, we look at a scatter plot. And all a scatter plot does is it looks at points of your X and your Y. And I'm going to go through a couple of examples of this. We're going to do one by hand, and then we're going to go into StatCrunch and see how easily it's prepared there. But we create these scatter plots so we see them, and then we summarize them. There's three things that we look for, and I'm going to teach that to you in this video. So in looking at a scatter plot, we look for three things. First of all, we want to see is the relationship linear or not linear. If it's linear, then there's some cool things that we can do with correlation and regression at this level. If it's not linear, we kind of shut the door on those types of problems in this class. Now, there's things we can do at a higher level, but we don't learn that. So the first thing we want to do is eyeball the scatter plot and see if we have a linear relationship or not. The next thing we want to see is the direction. And we want to describe it as being either positive or negative. If we have a linear trend, so we're going to make these dots, and they're going to form some sort of shape. If we have a trend that rises to the right, then we call that a positive relationship. On the other hand, if we have data that kind of falls off to the right, then we call that a negative relationship. So linear or not linear, positive or negative. And then the final thing, we're going to look at the strength. Is it weak, moderate, or is it a strong relationship? A weak relationship has very little linear tendencies. We can kind of see this thing rising to the right, but there's not a lot of cluster around an imaginary line that goes right down through the center of our data. So gang, this is a weak relationship. A moderate relationship gets tightened up a little bit. It has a little more, if you can imagine a kind of an imaginary line down the center, it has more variation here than the one I'm going to show you that's strong, but has less variation, and we probably should actually put a few more dots out here across from the away from that imaginary line. So this variability across this line that goes through the center of our data has more variability, and as I visualize less variability around that line, it moves into the moderate phase, or the moderate stage. Now, a strong relationship, if we visualize that line going through the center of our data, has little variability. So guys, this would be a strong relationship. Now keep in mind that these things can be positive or negative. So we could have a strong positive, or we could have a strong negative relationship. So these things are pretty straightforward to learn, and especially when you start getting a few pictures and you're able to compare them. So let's just start out with some data. I like to have these concepts kind of as being data driven. So let's say that X is a student's ACT score, and Y is their first year college GPA. And let's say we've got some information here on some students. And we have 5 students. So the first student had a 28 on their ACT. In their first year they had a 4.0. And the next student had a 22 and they had a 3.4. We have another student with a 25 and they had a 3.2. And let's say we had a student with an 18 who had a 2.4. And let's say we had a student with a 15 who had a 2.0. What I could do is I could look at this, and I want my variable that is X to always be the one that comes first. I want my variable Y to be the one that comes second chronologically, or the variable that we're trying to predict. Now, we'll get more about that when we get to linear regression. But right now, most people take their ACT before they go to college. I know that, maybe your nephew did it, whatever. Most people take the ACT before they actually end up going to their first year of college. So I'm going to let my ACT be my X, and I'm going to let Y be the first year college GPA. Now what I got to do is I have to set my axis here on ACT to accommodate the data that I have, and the data ranges from 15 to 28. So I'm going to come in and break this up and again, guys, I would never do a prepare a scatter plot by hand. I would always use technology, but I like to demonstrate things by hand, and then use technology to get a much prettier picture. What would happen here? We see our GPAs range from 2.0. I'm going to break it up. Okay, so I'm going to come in and start making points. So this guy right here, or girl, I have no idea, I don't have gender, at a 28, so I'm going to come out here to 28. I'm going to go up to 4.0. And that point represents this student. 22, 3.4, so 22 is about right there. 3.4 is about right there. That point represents that student. 25, 3.2. 18, 2.4. And 15 is a 2.0. All right, gang, how are we going to summarize it? Is it linear? Does the overall shape of the points form something as linear? Now, it may help to see, well, what isn't linear? Well, guys, if I had something that looked like this, in no shape, form, or fashion can I say that I can draw a line, hence linear, and that this cluster of points is well fit by a straight line. So guys, this is not linear. Can I say that this cluster of points is kind of well fit by a straight line? I think it is. Well, in fact, I don't even think it is. I know it is. And actually, I created this these numbers to make it linear. So I would say yes, linear. The next thing I want to know is a positive or negative. Well, we talked about earlier, if we have an increasing trend, then we have a positive relationship. Next thing, strong, weak, or moderate. Well, guys, go back to your guideline here. Are we all spread out? Are we kind of spread out? Or are we tighter around the line? Well, guys, I think that's tighter around the line. I think we would all agree with that. So we would have a strong relationship. Now, what does that mean? Let's focus on this one right here. A positive relationship. What does that tell us? That tells us that as our X value gets bigger, as a student has a higher ACT, we can expect a higher first-year GPA. So for students who have a higher ACT, we expect a higher first-year GPA than for students who have a lower. Now, a lower ACT. Now, what if it was reversed? What if something happened wacky with a data set of this nature where we had ACT and we had GPA and we had something like that? Well, linear, yep. Positive or negative? Clearly negative. But what happens here? As I compare a lower ACT with a higher ACT, the lower ACT seems to have a higher GPA, and the higher ACTs tend to have a lower GPA. So a negative tendency says is our X variable increases, our expectation of the Y variable decreases. So, and then guys, sometimes you just get into, you see this happen a lot. Well, I don't know about a lot, but you see it happen quite a bit. What if you have something like that? Well, is it linear? No, it's not linear. So guys, once it's not linear, stop the process. This stuff that I'm teaching you in terms of correlation and regression is not applicable. I mean, we could fit a line to it, but it would be kind of goofy. So again, this correlation regression stuff that I'm going to teach you, we need to start with a linear relationship. And guys, it doesn't have to be great. It can have a lot of variability. It can be a weak relationship. It can be a weak negative. We can still implement some regression techniques. We just have to be careful using this model that I'm going to teach you later on in how we use that to make predictions. All right, guys. Something I have noticed as I've taught and become a professor and done things is people typically really don't care anymore what you think. They want numbers to support what you're thinking, right? When you go to a conference and if you present some findings, I just did some research with the occupational therapy department here at Shawnee, and we were looking at some fall data, and people wanted numbers. They didn't want us to say, well, yeah, I mean, people seem to fall as they get older. They wanted numbers to verify what we had found. So it turns out that these scatter plots that we use to see and summarize can be done more quantitatively with something called a correlation coefficient. Now, the formula to find the correlation coefficient is a big old fancy formula. We're not going to get into that at this level. I think it's much more important for you to know what this does for us than to sit around and calculate a bunch of them. If we want one of these, we'll plug our information into StatCrunch, and we get the correlation coefficient instantaneously almost. What I want you to know about the correlation coefficient is this. This thing measures the strength of the relationship between two quantitative variables if a linear relationship. So guys, the key, we need to look at the scatter plot, see if there's if there's reason to believe that the relationship is linear. If so, we can implement this correlation coefficient. And just get a numerical summary that provides more information about the strength of the relationship. Guys, a little bit about this R. It will always fall between -1 and +1. So if you are to look on a number line, which goes from positive infinity to negative infinity, centered at 0. So we go to 1 and 2 and 3 and 4 and a million and so on. This R has to fall between here and here. If someone says that they ran a calculated correlation coefficient and got a value of 1.7, then they made a mistake. That is impossible to do. This value has to be between -1 and +1. Now, breaking that down a little more, let's just look at the graph of the part that is applicable to us from -1 to +1. It's a pretty good rule of thumb that you can come in and look at from -0.8. I don't know if you guys can hear that or not, but it's raining pretty hard, and I'm on my back room putting this up, so hopefully that's not a distraction. And from -0.2, +0.2, and positive 0.8. So break up your number line in this fashion. It probably doesn't mean anything to you yet. I'm sure it doesn't. But this gives us kind of a good rule of thumb on what this correlation coefficient tells us. Guys, if our correlation coefficient falls from negative 0.8 to negative 1, that tells us that we have a strong negative relationship. If we have a correlation coefficient that falls from 0.8 to plus 1, then we have a strong positive relationship. Now, this is one of the toughest things to wrap your mind around with correlation coefficients. A correlation coefficient of negative 0.72 and a correlation coefficient of positive 0.72 indicate the same strength. The strength of the relationship is exactly the same here and here. The difference is this would have a negative tendency. This would have a positive tendency. But the relationship would be exactly the same. The magnitude of the relationship is the same. The direction is just different. And the direction coincides with the sign of the correlation coefficient. From negative 0.8 to negative 0.2, we can accurately classify this as a moderate negative relationship. And we can accurately or get a pretty good indication of a moderate positive relationship from 0.2 to 0.8. Guys, anything between here and here, we would refer to that as a weak relationship. So if it's from 0 to negative 0.2, it's a weak negative. If it's from 0 to positive 0.2, as you would expect, it is a weak positive relationship. All right, gang, what I want to do is I want to get out of this. I want to go to my math lab. Well, maybe not. I'm going to sign in. Should have already had this done, but and plus my internet connection will probably be extremely slow because every time it rains it goes out. But AT&T tells me it's just fine. I have proof, quantitative proof, that they're wrong, so but they don't care. Alright, blazing fast speed here, guys. Let's go to the StatCrunch website. I want to enter my own information. So, guys, I want first variable to be ACT. Imagine that. I want my other to be first year college GPA. Alright, gang, I'm going to type the numbers in that I had earlier. I had a kid with a 28, another one with a 22, another with a 25, another with an 18, and I think the final one had a 15. And the first year had a 4.0, 3.4, 3.2. It's not that I remember this. I'm sitting here looking at it. 2.4 and a 2.0. All right, to look at a scatter plot, we go to Graph. It's really easy to find. It's under Scatter Plot. Imagine that. My X variable is the one that comes first. In this case, that's going to be ACT. My Y variable is the one that comes second, first year college GPA. You know, I can get into some fancy stuff here, group by, just different things. But I think I'm just going to go with the defaults here. So I'm just going to compute. And when I get this, I can see that, just as I said before, I have a linear trend. I have a positive relationship, and I have a strong relationship. Now I can get into more stuff. So I'm going to go to columns. Wait a minute. I don't think... yeah, I can't do that. I need to do something else. Let's go to correlation. ACT. First year GPA. I don't want to group. And let's go. So guys, I can see there that the correlation between ACT and first year GPA is 0.97. So when I go back to my chart that I had before, 0.97 would fall about right there. So I can see that I have a strong positive relationship between high school GPA, or I'm sorry, between ACT and first year college GPA. All right. Well, guys, that's all I'm going to do in this video. We'll get into something in the next video called the coefficient of determination. But that's all for now. Take care.